Of the hydraulic steering system. This vehicle uses a cam and lever steering mechanism consisting of the following components: a steering shaft and cam, a Pitman arm lever, a Pitman arm shaft and Pitman arm, a drag link, and a tie rod. To obtain the assist, a hydraulic system has been added to the cam and lever mechanism. The hydraulic steering system is made up of 5 major components: the reservoir, pump, relief valve, control valve, and power cylinder. These components operate on the principle of pressure differential. Pressure differential is illustrated by this section of pipe. In the pipe is a movable block. The arrows on either side of the block represent equalized pressure. As pressure on one side of the block is increased, a pressure imbalance or differential is created in the pipe, moving the block in the direction of the lower pressure. The moment the pressure on the opposite side of the block is increased to equalize the pushing force, the motion of the block is stopped. In like manner, as the fluid pressure is increased on one side of the piston will be moved by pressure differential, aiding in steering the front wheels through the steering linkage. To aid in illustrating the internal function of the hydraulic system, a schematic diagram will be used. The steering linkage from the Pitman arm lever to the front wheels will not be shown. Let us view the 5 major components of the hydraulic system as they operate progressively to deliver the steering assist. The reservoir supplies fluid. The pump, driven by the engine, delivers the fluid under pressure to the relief valve and control valve. The control valve, actuated by the steering shaft, directs the fluid to the power cylinder. The power cylinder converts hydraulic pressure into mechanical force by means of a piston. The control valve is the heart of the hydraulic steering system. The control valve has a spool which directs and controls the flow of fluid to the power cylinder. With the fluid removed, let us look at the internal construction of the control valve. The spool has lands which control the flow of fluid through the passageways to the power cylinder. The fluid enters the control valve through the inlet port and flows around the spool in channels leading to the power cylinder. After the cylinder has been filled, all fluid then flows to the reservoir. In order for the hydraulic steering assist to operate, it is not only necessary for the cam to rotate, but it also must be able to move up and down. A spline connection makes this possible. Were it not for the splines, the steering wheel itself would move up and down. The cam is held in center or neutral position by a spring at each end, supported by the steering gear housing. The Pitman arm lever, which actuates the Pitman arm, has one end fastened to the piston rod, the other in mesh with a groove in the steering cam. When the steering shaft is turned, it requires a greater effort to turn the Pitman arm shaft and lever than to compress the springs at either end of the cam. This is so because the Pitman arm shaft and lever are connected to the front wheels. This action causes a cam spring to be compressed, allowing the cam to move up or down, depending on the direction that the steering wheel is turned. This up and down movement of the steering cam actuates the control valve through the valve lever linkage. Full pressure of the hydraulic system is applied with only a few thousandths of an inch of control valve travel. In neutral position, all fluid flowing into the valve from the pump is returned to the reservoir through channels in the upper part of the valve housing, and no steering assist is being delivered. As the steering wheel is turned, the up or down movement of the cam actuates the control valve lever, shifting the position of the valve spool. The spool lands corresponding to ports on the valve housing direct the flow of fluid from the pump to the power cylinder. This flow of fluid causes an immediate pressure increase on one side of the piston in the power cylinder. At the same time, fluid from the other side of the piston is displaced by pressure differential and forced up and around the unrestricted passageway in the control valve to the outlet port leading back to the reservoir. The pressure differential in the power cylinder moves the piston and piston rod, thus applying a mechanical force to the Pitman arm shaft lever, turning the wheels in the desired direction. When the piston reaches the end of travel in the power cylinder, the pump continues to deliver fluid, causing an increase in operating pressure. The relief valve provides an escape for this excess pressure back to the reservoir. After completing a turn, the driver releases tension on the steering wheel, and the steering system is returned to straight-ahead position by the steering geometry of the front wheels, allowing the hydraulic system to return to the neutral position. To steer in the opposite direction, the cam actuates the control valve lever the other way, and pressure is now directed to the opposite side of the power cylinder piston. When the front wheels are held in a constant turn, the cam will not be rotated. The Pitman arm shaft lever is held stationary toward one end of the steering cam by the increased pressure on one side of the piston. The tendency of the steering geometry to return the wheels to the straight-ahead position is overcome by the driver, who maintains a constant force on the steering wheel in the direction of the turn. These two opposing forces cause the steering cam to partially compress the upper cam spring. This also moves the control valve linkage and positions the valve spool where fluid pressure will equalize the force exerted by the steering geometry acting on the piston rod. The front wheels can then be held in any desired degree of turn. On return to neutral, all fluid from the pump is directed back to the reservoir. The pressure is lowered throughout the hydraulic system, and the piston and piston rod do not function. One of the steering problems of the heavy vehicle with cam and lever steering is road shock. Road shock causes kickback of the steering wheel and makes control of the vehicle difficult. On the other hand, heavy military vehicles equipped with hydraulic steering resist road shock through a reverse action in the power cylinder. When one of the front wheels is subjected to road shock, The shock is transmitted through the steering linkage to the pitman arm and the pitman arm shaft lever. The pitman arm lever then actuates the cam, causing it to move up or down depending on which wheel receives the shock. The movement of the cam actuates a control valve, which in turn directs increased pressure to one side of the piston. This increased pressure will be equal to the shock received by the front wheel, causing the front wheels to remain in a straight-ahead position. Now let us review the operation of the hydraulic steering system. The reservoir supplies fluid. The pump, driven by the engine, delivers the fluid under pressure through the relief valve to the control valve. The relief valve provides an escape for excess pressure back to the reservoir. The control valve directs fluid to the power cylinder. The power cylinder converts hydraulic pressure into mechanical force, which in turn actuates the pitman arm shaft and lever and the pitman arm, turning the front wheels of the vehicle through the steering linkage. In order for the hydraulic assist mechanism to operate, the steering cam must be able to move up or down to actuate the control valve. A spline connection makes this possible. The cam is held in center or neutral position by a spring at either end. The slightest movement of the cam results in a pressure differential in the power cylinder and an applied force on the pitman arm shaft and lever and the pitman arm. The hydraulic steering system resists shock and kickback through a reverse